Okay, so I'm going to give a presentation on the topic waveform generator using the 8085 microprocessor as a part of our PHN 314 coursework. A bit of background. The microprocessor has created a significant impact in its various fields. The availability of low cost, low power and small weight computing capability allows user to use it in different applications, such that nowadays microprocessor based systems are used in automatic testing product, speed control of motors, traffic light control, etc. And one of the important application is the waveform generator. So I'll be discussing first the Sawtooth waveform code. So first of all, MVI ATH means load resistor A with immediate data ATH. Then out 83H means send content of A resistor to control word resistor. So and MVI A comma 00H implies load initial count. So we have begun the second loop first. Then out 80 comma H means send count value to port A of 81. Then we start the first loop. So INR A means increment the count value, then send count value to port A, and then CPI FFH means compare content of A register with the maximum count. So then we jump to loop 1 if the result of comparison is not equal to 0, and then we jump to loop 2 to repeat the process. So here is the output of the sawtooth waveform with the positive ramp. And then for the negative ramp case, there are only two changes. The third line loop 2, where the loop 2 begins, the MVI, we write MVI A comma FFH. So this implies load initial count, and then send count value to port A, then again decrement count value, and send count value to port A, then compare content of register A with maximum count, then jump to loop 1 if the result of comparison is not equal to 0, and jump to loop 2 to repeat the process. So here is the sawtooth waveform with the negative ramp. Then comes the triangular waveform. So we again begin with the MVI, ATH instruction. So that is load register A with immediate data ATH. Then send content of A register to control word register. Then load initial count. Then send count value to port A, and then increment the count value. So we have started the loop 1 and then send count value to port A, then compare content of register with the maximum count, and then jump to loop 1 if the result of comparison is not equal to 0. And then we begin loop 2, so that is decrement count value, and then send count value to port A, then compare content of A register with the initial count, and then jump to loop 2 if the result of comparison is not equal to 0, and then jump to loop 3 to repeat the process. So that is the output of the triangular waveform. So then the square waveform generator. So first of all, load the stack pointer with immediate data of 2000H, and then load register A with immediate data ATH, and then send content of A register to control word register, and then repeat. So load maximum count into A register, and then output then send data of A register to the port A that is marked by the address ATH. So then go to delay subroutine, and then load minimum count into register A, and then send data of A register to the port A. Then go to delay subroutine and jump to repeat to generate the square wave continuously. So and then load delay count value into register B, and then decrement delay count value, jump to loop 1 if delay count value is not equal to 0, end of subroutine, and return back to the main program. So this is how the square wave form looks like, and that is all from my side.